Today we're going to be installing the Easy Generator switch. This is a really high quality American-made product that basically allows us to take any 120 volt power supply and connect it to any 120 volt load. Now, one of the most common situations that you're going to be using a box like this for is powering a gas furnace. So that's exactly what we're going to be doing today in this installation. Now, we are going to be installing this directly to the panel, and the benefit to that is that you guys are going to be able to see how to connect this to any of your 120 volt circuits that are in the panel. So if you don't want to connect it to your gas furnace, but you want to connect it to a circuit that has your freezers on it, or a circuit that's got your lights on it, that's going to be the same exact process. You just choose which circuit you're going to be powering. Now, one of the really cool things about this particular switch is it actually allows you to switch the neutrals, which a lot of transfer switches do not have that capability. And we're going to talk more in detail about whether or not you should switch the neutrals after we do the installation here. But to start off with, we're going to be doing this as a non-switched neutral installation, which is likely going to be the most common scenario. It really comes down to whether or not you have a floating neutral power source that you're planning to use or a bonded neutral power source. So I'm going to be testing this battery backup unit right here, as well as my gas generator that I have right outside, to see if those neutrals are bonded or not, so stay tuned for that. This video is not being sponsored by Easy Generator Switch. I actually talked to the founder.
Hey Ben, how are you?
Super cool guy. He's a master electrician and is very passionate about this product. The only thing that they did is they did send me 2 sample units. Other than that, they're not paying me to make this video. And one cool thing that Kevin was willing to do was to set up a discount code. So if you guys click on that link in the description, you will get a discount on this unit at the time of recording this video. And I believe that they're going to try to continue doing that, but it may not be forever. So check it out.
So China took my switch. He opens up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 companies. He duplicates my unit, uses my wording and everything. It's almost
So
comical.
sad, yeah.
When you get my switch, you look on it, Intertech, my number is 5,000,010. That number is assigned to my switch with my testing, with my everything.
Right.
When you look at his number, it's assigned to the company that makes just the inlet. So he took he just took their ETL and said, hey, here you go, it's approved. No, the inlet's approved, nothing else is approved. This is the distinguishable thing between us and China, besides product, is if they have a problem, email us. We will definitely handle it. Most likely I will handle it because I don't get that many problems. We don't advertise, good for a year. Listen, my product's good for as long as you own it. My product is as good for as long as you own it.
So just keep those things in mind when you make your purchase decision. Let's jump into the installation and then we'll come back and talk a little bit more about switching neutrals or not. This transfer switch is set up so that it switches both the hots and the neutrals. And that's actually really important if you have a bonded neutral generator or power source. Almost all power stations are going to be floating neutral. And what that means is that the ground and the neutral are not going to be connected together. And we can tell that by switching into continuity mode with an electrical tester. When I cross these, it makes a beeping noise. So if we go from the wider slot right here to the ground prong, there shouldn't be any continuity, and there is not. So that means that this is a floating neutral power station. We're in continuity mode now. And if we go between the ground prong right here and the neutral prong, you'll see we have no connection. And honestly, it seems like the majority of small generators and power stations are typically going to be floating neutral. Real quick, let's go over the design and features of this thing, as well as a little bit about how it works. You can see if we put it in the down mode right here, this is going to be connected to the grid. In the middle, it's going to give us disconnection from both the grid and the generator, which is important because you need separation between those two. You never want your generator to be connected to the grid because you could backfeed the utility. And then in the up position, that does connect to our generator or our power source, and that's going to be going through this 15 amp resettable breaker right here, and then over to our NEMA 15 amp inlet. This inlet specifically is designed for 15 amps, which is why the entire switch is technically rated at 15 amps in order to use this standard, most common plug configuration. Coming around the back, you can see on our inlet we've got 3 different wires coming out. We've got a ground wire, a hot, and a neutral. And that hot is going to run over through our 15 amp breaker that we already talked about right here. And then it comes out of that 15 amp breaker and into our 3-position switch. Now our 3-position switch is separated into 2 halves. On the right hand side you can see we've got our hot wires, and on the left hand side we have our neutrals. On the bottom is where the power is going to be coming into the switch from our inlet, and on the top is going to be the power coming in from our breaker in the panel. The middle wire right here is going to be going out to feed whatever load we are choosing to attach this switch to. Now on the opposite side with the neutrals, it's doing the exact same thing. It's basically switching over where our neutral is connected, whether it's going to be connected to the panel through this wire right here, or to the generator through this wire down here. And then this middle wire would be going to our neutral for the load. Now, if we want to convert this thing to be a non-switched neutral switch, which is exactly what we're going to do, all we have to do is remove these wires, take all 3 of these off, because we just don't need them. And instead of having this pigtail, we're going to connect this directly to the neutral bus inside of our panel. Or if you were doing this at the furnace itself, you would just wire nut a wire from the existing neutrals into that terminal right there. With those removed, we are ready to go ahead and mount this on my panel. Always make sure you disconnect the power from your panel when you're working in it. I'm going to install my transfer switch right down here at the bottom of the panel, but note that it might not be a bad idea to install it closer to the actual circuit that you are going to be powering. So putting it right up over here on this side probably would be a good idea, but I just have a lot of wires in the gutter here since I have all the pigtails going to my arc fault and ground fault breakers, so we're just going to keep it down at the bottom, and I might have to extend my wires up to the breaker that we're working with. Go ahead and reattach our switch to the ground. Then we can feed our ground through our offset. And then we've got 2 hot wires that are going to come up into the panel. One of these is going to be going to our load, which is the wire that is going to the breaker for the furnace. And the other one's going to be the line, which is going to be coming from that same breaker. Let's go ahead and land our ground wire. You can land multiple ground wires on the same terminal, but if you've got plenty available, you might as well just give them each their own. Okay, that's done. Now we're just going to pull a neutral wire through. I'm using one that is a new piece because the one that came with it was a little bit too short since I'm mounting this thing all the way on the bottom of the panel. Always good to use an insulated screwdriver whenever possible, especially if you're working in a live panel, which you should never be working in a live panel, right, in theory. I'm using 12 gauge wire here, but technically it wouldn't need to be 12 gauge, it could be 14 gauge. Because this is a 15 amp transfer switch, but it's always fine to go a little overkill. I'd like to route that a little bit better. I think I'm going to pull it back up. This is where my OCD kicks in. And we'll just connect our neutral to our neutral prong here on our inlet plug. That takes care of the neutral. Now we just have our hot leads that we need to deal with. Circuit number 6 here, this is what's feeding our furnace right now. So we just have to remove the wire that is going out to the load or the furnace. Take that off, pop it free, like that. The standard wires that came on this thing are almost long enough, but not quite, so we're going to have to run some new ones. Now we'll just take our red wire coming from the transfer switch. This is what's going to be feeding power down to the switch so that it can control which source it's going to use. So we'll put that onto our breaker. Get that snugged up good. This wire right here is what goes to the furnace. This is the wire coming from our transfer switch box. And basically our switch is going to determine whether the power from this breaker right back here is going to be sent through to the load, or the power coming from our generator or power station. Now we're going to use an Ensure lever connector. I don't know if you guys have seen these before. These are made by Ideal. I will link to them in the description. But one cool thing about them is that you don't have to open the levers like you do on a Wago, where you have to open it first before you push them in, officially anyway. So these you can just go ahead and stick it on here and push them right in. Just like that. And we can still visually inspect on the end right here that they are pushed all the way in and fully seated. Now it's super easy. If I ever want to switch back, I can just put the wires back the way they were before. Now we'll just connect our red to our red and our black to our black down here. And I am going to junction these inside of this box down here. Since we are connecting stranded to solid, we won't be able to just push it on both sides. We'll have to push, we can push it on the first side, and the second side we need to actually open up like that. Perfect. There we have it. Let's go ahead and turn our circuit breaker on to the easy generator box. And then right down here we should be able to switch it into normal mode, and it should right away connect our furnace. Yep, and it started just like I expected it to. So we are officially ready to connect our power station to our inlet box here right here. This is going to be super cool. All right, all we have to do is connect our extension cord now to the power station and take the other end and plug that into our easy generator box and then flip it into generator mode. And I did hear a click right away. That's a good sign. There we go, 19 watts, 27 watts. It's working, you guys. We are running on battery power for the furnace right now through our generator switch. I definitely should put a cover on the panel though now that we have it turned on again, huh? Now that we got the switch installed, let's talk a little bit more about whether or not you want to switch the neutrals. And it's really going to come down to what power source you are using.
Got the same thing, the exact same problem with the Ford F-150 Lightning trucks.
Oh, really?
They have, now watch this, this is interesting, this kind of gets a little confusing. They have a GFI, a GFCI on the back of that truck that feeds, that is your feed to go out, your 110 feed.
Right.
So a guy will call me, he goes, listen, I got an F-150. I said, well, but you have a GFI. He goes, yeah. I said, well, here's the difference. That GFI is bonded somehow in there. I don't know where they did it. But that GFI looks downstream and says, is the hot leg clear? Yes. Is the neutral clear? No, because you rebonded it to ground. It would trip. So in the case of a Ford F-150, you have to use my switch as you receive it. You have to switch to neutral because the GFI goes, whoa, 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 you can't bond the neutral again. It's already done.
Yep, exactly. And that's where I feel like for some people, you might, if you have multiple different generators, like if you have an old school one that's a bonded neutral generator, then you want to switch the neutral and the switch, obviously, but then you've got your new fangled battery pack or an inverter generator that has a floating neutral. Now you don't need it. So it's like you almost need a way, like I was thinking about it, you could do it with like a three-way switch or something where you basically flip it into one mode or the other.
Correct.
And so I was considering talking about that as a possibility. You'd put a box next to it and use that switch to choose which mode you want to go in. But I think probably 90% of the time or more, it seems like eliminating the neutrals, the switch neutral is the way to go.
Yeah, and here's the other thing. If you have an old generator and you switch the neutral, it doesn't care because it's not smart. It's just putting out this current. So a lot of people with a new inverter and an old generator, they can still run them together, and they don't. I don't see that many issues. It appears to work fine.
Run it with with the neutrals bypassed, right?
No, even without, because the old generator has a bonded neutral.
Yeah, so it sees it. It's not going to cause an issue with the furnace control board.
Right, exactly.
If you know for a fact that you have a bonded neutral generator, meaning that the grounds and the neutrals are tied together at the windings inside of your generator, then you are going to want to go ahead and switch the neutral. And the reason for that is that if you do not switch the neutral, you are going to end up with a situation where you're bonding your neutrals and grounds in more than one location. And doing that is going to cause current to flow on the grounding conductors or the grounding system, because when you bond at more than one location, it creates more than one path back to the source. So you will actually have some objectionable current flowing on ground wires, which is something that we want to avoid in every situation. Now, if you don't really understand that concept, there's a video that I'll put right up here that talks in depth about why neutrals and grounds are separated. And I actually demonstrate in this panel right here a way in which, when we bonded the neutrals and grounds, caused several amps of current to be flowing on my grounding conductor back to the main panel out in the yard. So it's a really interesting concept to understand, but that's really what it comes down to. By code, you can only bond in one location. Now, one cool thing is that a lot of generators, if they do ship with a bonded neutral, you typically will have instructions with them that allow you to remove that bond and allow it to be a floating neutral power source. The only time that you really want a bonded neutral generator is if you're using it on a job site and in an application where you're not connecting it to any equipment like this, you're not connecting it to any electrical equipment, you're just using it with extension cords. In that case, a bonded neutral is actually a really good thing.
You know, people go, if you owned both, what would you do? And I said, I would wire it for the better generator. We try to line everything up correctly with the National Electrical Code. When you talk about portable generators, the better ones, the Yamahas, the Hondas, they're all floating.
They're all floating now. Everything seems to be going that way, and that's where it's like, well, the neutral, switching the neutral is awesome, but you're probably not going to need it going forward.
Right. Exactly.
And that's where I feel like you would almost benefit from having it by default in that mode, because of the way everything is going. Obviously,
versus the other way.
Right.
Yeah.
Yep. And then convert it if you need to switch the neutral instead of converting it if you don't.
For floating.
Yeah, but obviously you've had it set up this way for so long, it's not like it doesn't really matter, but.
It's funny you should say that, because we discussed that like a couple of months ago, and we kind of left it on the table. We went, wonder how many people, that was one of the questions we pondered. We go, I wonder how many people have to convert my switch. Like, do more than 50%? Because that would be the key, right? If 50% do and 50% don't, well, then you're even. But if 75% of the people need to do it, well, maybe we ought to send them out that way. When we first started, in the very first year, you checked off a box, floating or bonded. And the problem there was people go, how the hell do I know? I don't know what I have.
Oh, interesting. So then you would send it out in the configuration based on their equipment.
And based on how they ordered. But out of 100 people, 99 came back and said,
what do I have?
I don't know. What do I have? And so what did we do? Okay, I compile a database of every single generator made in the United States and Canada and find out through either calling the company or testing them which ones were floating and which ones were bonded. I still have that database.
Before, your regular furnace, it didn't really care if it was a bonded or floating neutral situation feeding it. It just wanted the difference across the two legs, and it was happy.
Right, exactly. And I'm going to tell you who started the whole thing. Lennox. Those are the people. Lennox. Those are the troublemakers. Those are the ones. And then it went from Lennox, it went to Baderis, which was made in Germany, and then it went to, I would say the next one was probably Carrier. And now it's primarily Lennox and Carrier still are the fussy ones. We're gonna take another closer look at just sending them out, set up for floating, and if you need a bonding one, here it is.
Now, one super cool thing that I mentioned to Kevin on the phone was the fact that when you do this conversion, you are actually leaving that second half of the switch open that's not being used for anything. So when I click this back and forth, I actually have the opportunity, if I wanted to switch a second load onto this switch. And that's what we're going to do in an upcoming video. I'm going to show you how to use the Easy Generator switch to power two 120 volt circuits, which is going to be super cool.
You're right. The answer is, right now, today, is run your inverter. When it starts getting low, start your generator, recharge your inverter, shut your generator off so you don't need that, hear that screaming going on.
Right.
And you're not using the fuel. There's no question that's the way to go right now.
Since we've touched on whether or not you should connect your neutrals and grounds, I think that this video right here is probably the most applicable one to help you really wrap your mind around why we separate the neutral sometimes and why we only bond at one location. We'll see you right there.
We get tested every 90 days here. They come in, they go through every single piece of product.
Really? I did not know that. It's not a one-time deal?
Oh, no. People go, oh, your unit's $90, whatever. Yeah, I got testing. I get tested every 90 days. Even my test equipment has to go out and get certified to test, to maintain it's within the parameters. So that's how China reduces pricing on everything. People don't realize, whoa, how could you be, this is $20 worth of parts. Yeah, I wish.